Hey guys, welcome to episode 2 of Introduction to Computer Networks. This is Polly again, streaming live from NTU. So yeah, hi, good morning. Good morning, Cassandra, Hongming, LA representation, Tosha ET, Yu Jie, and Yuan Hao. By the way, so maybe I can clarify it again. I guess some of you probably had trouble finding the lecture yesterday. Yeah, that was the first lecture. I do see students often missing the first lecture for this course particularly. Yeah, hi Bo Sai and hi Ming Hong. I hope I pronounce your name correctly. If I don't, let me know gently, all right? So let me clarify this. Yeah, there's a Google Meet link that I post on the announcements, and this is going to be every week. But this link, guys, it's more for Q&A before class or after class. And it's also for some of the QAs, we do need real-time interactions, because interactions between me and you over the YouTube chat can have some delay. So it's not necessary that you tune in here on the Google Meet, especially during the lecture hours. All right. And hi, we see more students popping up. Yongyi, Qingying. Okay, sorry. Hey. Yeah, so if you show both the Chinese and the English name, that will be very, very helpful. Yuling, Amy, hey, this is great. This is like an exemplary student here, right? Cheng En and Jia Xuan and Eslam, hi, and Ting Xuan. All right, a good day to all of you. All right, so the announcements are again the link to the lecture and the Google Meet session. Now, what's new today comparing to yesterday is this. Polly has a committee meeting from the department to attend, and that will happen during the office hour today. Recall, yesterday, every Wednesday, the lunch hour is also our office hour. So the Google Meet session is going to be online there. Polly is going to be here all the time. So in case you want to ask questions or discuss things more interactively. But today we need to cancel that because of the committee meeting. This is not like a meeting that's going to happen every week, so we just cancel it today. That said, if you have questions you want to ask, feel free to post it on the Ask Us Anything channel. Okay, Polly and the rest of the class should be able to help. Okay, good. Now, let's go on to the topics today. So today, it's going to be in 3 parts. First is what remains from yesterday. We have not yet talked all about the class design and the administrative details. Okay. Second is going to be a very, very high-level overview of the internet. And the third is going to be a little bit more specific. Given the high-level overview, we'll then talk a little bit more to this particular part of the internet that surrounds the edge of the network infrastructure, so the internet edge. Okay, so let's start with the first part. The first video is the schedule of the semester. It's quite straightforward and very short. Semester is divided into 3 parts. In the first part, we have 5 weeks of lectures and we follow that by an exam. The second part, 4 weeks of lectures and an exam. The last part, similarly, 4 weeks of lectures and then exam. Now, in terms of topic going backwards, we'll be talking about the link layer protocols and the network layer protocols in the last part, and a lot of transport layer protocols in the second part, and then the application layer protocols and the overview of the internet, the first part. Now, in terms of assignments, we'll have 3 PAs due the first part. The first 2 are simpler, but the third one is very challenging. So to be said, you definitely want to start working on PA 3 from week 4, where there's no PA doing. Now, the second part, we have 4 PAs doing back-to-back. No worries. Yeah, PA 5 and 6, unlike PA 3, these 2 are a little bit more straightforward. So this is to balance the load a little bit. Now, the last part, we have only 2 PAs due, but PA 8 here could be a little bit challenging for some of you. So again, start PA 8 from week 12 to be safe. right, so 3 parts. Okay, the semester, 3 exams. Okay, and each corresponds to a particular chapter in the textbook. Now, grading. Okay, so this is very important, guys. You want to pay attention because quiz number 2 is all about the grading policies. Okay, this first video is just to give you an overview of where you're going to earn grades. Now, let's talk about how you earn grades. You will earn the grades in 3 categories. The first one is called homework. You'll be working on these programming assignments, also known as the PAs. There are 9 of them. First one is straightforward, counts only for 3 points, but the rest of the 8, each 4 points. So together, 35 points to earn here. In the second category, interaction, that includes the quizzes as well as the participation. There will be about 50 of these quizzes that will pop up during the lectures. Altogether, you will earn 30 points. How much more you earn out of the 30 points depends on how complete you are answering all these quizzes, as well as how you are more responsive, meaning faster answering the quizzes, as well as how you are more thoughtful and the answers are more unique. Participation. This counts all the interactions between you and the class. Okay, so asking a question or answering questions from others in the class will all count. And interaction through all kinds of channels such as Discord, email, YouTube live chat session, as well as the Google Meet video session that you might be using for office hour. So all of those counts, and together maximum 5%. Last category, exams. This one is straightforward. There'll be 3 of them, each counts for 10%. And this is another way to break down the 100 points you'll be earning. PAs and quizzes, together 65 points. You'll be working a team, so these will be teamwork. Participation in exams, together 35 points. This will be work as an individual. But, from the proportion, you see that it's very important how you are working as a team. So each team will consist of 1 to 3 members, so this is in case you are a loner, and 3 is the absolute maximum. But the same group of people, you'll be working through the semester for these assignments. Now, every now and then, some students will ask to break up, and that is allowed. All right, so you see the team is important, right? Good. Now let's dig in a little bit more into each of the categories. So first is the PA assignments. Okay, homework assignments. So these are the 9 PAs. They are the golden programming assignments. For the purpose, we'll be setting up a Unix workstation. Each of the team will be given an account so that you will submit your code and test it also on the workstation. The TA and I will be grading your assignment based on how well your code runs on the specific workstation. Stage 1 of the PAs consists of 6 assignments. And the goal is for you to learn how to create a TCP socket, establish a connection between 2 processes on the internet, and pass some data around. Okay. And we'll be doing this through a toy internet service that is allowing file uploads. Okay. So you'll be implementing a client that uploads a file and a server receiving the content of the file and storing the content into another file. File upload, file transfer service. Just a little bit more about each of the PAs, all right? PA 1 is for you to learn some Unix commands so you know how to work around the Unix workstation at least. Second, using Golan to access files. Okay, this is about reading from a file on the hard drive, maybe do some processing and then write change back to the file. Okay. I have assumed that you know how to do this using at least another language that you learn from the programming class, such as Python, C++. Okay. And more seriously, from PA3, and it's going to be a little bit challenging. You'll be writing the client side of the file upload service. So your client will create a TCP socket and establish a connection and connect to the socket of the server that the TA and Poly has already set up running on the workstation. PA4 asks you to switch sides, so you will be the one writing the server and allow your own client to connect. PA5 is to extend the server such that your server not only read from a file once and then done. It will continue to loop, taking a file and then back to wait for another upload. Taking a file, wait another upload. So you could handle multiple uploads sequentially. And finally, PA6. Just like all the servers for the internet services these days, they should be working, of course, looping forever and seemingly handle multiple clients uploading files simultaneously. Okay, so parallel multiple uploads at the same time. Okay. Stage 2 of the PAs consists of only 3 assignments, okay, but they are not easier. The goal is to learn about this web server implementation that is built in already in Golang. So one doesn't need to implement the web server from scratch. Instead, reuse the existing code and create your customized web server. Let's talk about each of these PAs also a little bit more. Now in PA 7 and 8, we'll introduce the function calls and some of the lower level codes of the web server in 2 parts. One is the request interpreter, the other is the response sender. So the request interpreter and the response senders are the 2 very important parts that compose a web server. So web server is first receiving web requests from the client, understand what the request is asking for. That's why it's called the interpreter. And then the server can generate a response and sends the response back to the client. Okay. And finally, in PA9, we'll make this web server a secure web server, which is the default standard these days for any internet services. You want your server to be secure. All right, so those are the PAs. And you know what? These PAs are more or less independent of the lectures. So what that means is that, hey, you can now, for example, from the course page, okay, click into the Golang link here and see the 9 PA assignments and start working on it now, right? So for each of the assignment, you will find a PDF description of it. So for example, for assignment 1, it's called Unix command. If you click into the link, you will see the PDF description. Okay. Now, in order to start and get access to the workstation, definitely check out the PA1 channel, okay, on Discord. Now, you can follow this description and try to complete the assignment. Now, in case you run into trouble, you're not quite sure exactly what to do, or if you try to do something based on intuition, reading the document, and it's not working, no worries. For each assignment, there's a series of companion videos that is poly, okay, demonstrating what's described in the PDF document. Then you will see what exactly poly meant in the description. Okay, so with the PDF description and the walkthrough videos, it should be relatively easy to carry you through all the assignments. All right. So the PA assignments are designed such that it will be more or less a self-learning experience. Okay, but it's a better organized self-learning lessons. Now, in case you still run into troubles, yeah, especially when PA 3 and 4 started, okay, you might still run into troubles. When you run into troubles, definitely discuss with your teammates. Okay, if not, then hey, guys, did I mention that you can post questions on Discord, the Ask Us Anything channel? But for PA3, you want to post it on PA3 channel. For PA4 specific questions, you want to post on PA4 channels. And guys, those who know how to get around those problems, feel free to share, okay, what you did to get around the problems. Okay, so that's how self-learn exercises can be completed, achieved with peer helps. Okay, so you see that the style of learning is a little bit different as well from this course. Okay, but this way of learning is very similar to how more professional people self-learn these days, okay, in the industry. All right, so we have, of course, videos helping people understanding text-based description, and then we have places like Reddit, okay, to help people, or Stack Overflow to help people reporting bugs, and then those who are more experienced can answer the questions and help debugging the bugs. All right, so that was PA. Now, second, the easier part, the quizzes and the participation part of the grades. How do you earn these grades? The in-class quizzes, these will pop up randomly during the lectures, and they're related to the topics we're talking about. So for many of these quizzes, you'll be given time to work on during the lecture. So I would advise that you guys establish some sort of channel within the team so that you can have some sort of discussion before posting the team solution on the score. There's going to be a channel on the score per quiz, so it's hard to miss. Now, to earn the grades for the quiz part, you can solve it in class or off class, depending on whether it's take-home or not, and just type your solution up. In one of the quizzes, you'll be invited to speak and interact directly with Polly if you are lucky. Okay. So again, post your solution on the score and do it by Saturday, 6 p.m. Of the week that we posted the quiz. And so it'll be first graded on the completion rate, and that would add to 25% of the semester grade. And 5% will be reserved for those solutions that are particularly fast or thoughtful. So take your time for some of the quizzes, and for some quizzes, you want to be fast. There's a penalty for the late submissions, guys, so be careful. If it's beyond the deadline but within an hour, 10% deducted. If it's more than an hour beyond the deadline but within 6 hours, 20%, and so on and so forth. All points will be deducted if it's more than a day late. Class participation part of the grades. So this is easy. All interaction counts, but be careful. In order for the TA and I to count your participation, you need to let us identify you, all right? So make sure that on the YouTube chat, Discord, or in our emails, or when you join the Google Meet session, you use an ID that is recognizable, similar to your university record name, okay? And so let me and the TA and the other students know who you are. And the participation points will be scaled to the min and max of all the points assigned to the participation part of the grade. So that will be 0 to 5. All right, so those are the quizzes and the participations. And the quizzes, you see that by just completing the quiz, you earn only the basic, the 25%. Now to earn that extra 5%, you want to be sometimes faster and sometimes more thoughtful. Okay. Today you will see in quiz 3, I will be looking for thoughtful solutions to do that extra credit. Okay. That means though your answer for that quiz will be added to the extra credit, extra 5% of the quiz grades. And participation counts all the score interaction as well as the chat, YouTube chat channel, as well as email exchanges with the Polly and the TA, as well as Google Meet interactions. Okay, for example, earlier Pinxiang had interaction with me, all right? So by the way, hey, when you are joining the Google Meet session, make sure that you use an ID that I can recognize. Similarly, for the YouTube sessions here, use an ID that Polly can recognize so that we can count you towards the interaction part of the grades. All right. Now, if you have been using a nickname previously, definitely send Polly an email or post down the score. Let me know which ID that you've been using on YouTube chat is you. Okay. Now, exam. Okay, this is easier. Easier in a way to explain it, but it's not easier for you guys to work on. Exams. There are 3 of them, each 10%. The questions on the exams are all in these Q&A forms. I would advise that you go to the class page and go through some of the old exams to get a better idea. And for this semester, sorry guys, no early or makeup exams, please. There's also a penalty for the late exam submission. So if it's late but within a minute, 12 points deducted. Beyond 1 minute but within 2 minutes of the deadline, 25 points deducted. So if it's beyond 3 minutes, all points deducted. For every exam, you will receive a score after grading, But you see that in the end of the semester, when we are calculating the semester grades, we'll try to adjust the exam scores because the class average per exam can vary from exam to exam because of the difficulty or because of the length of the exam. All right. So we will adjust such that all three exams will align to the same class average. And that adjustment is a simple constant shift. All right. Last but not the least, guys, you don't want to cheat. You can do better than this. All right. But in very, very unfortunate case that we discover cheating behavior, 0 will be granted for the whole semester and the case will be reported to the department and further up to the university. Yeah, so hey, so Holly was thinking about cheating. I don't know about you. When I was growing up, I was thinking all the time, can I just be myself? Okay, I resent my parents' requests or comments a lot of time. Okay, but if you think about it, cheating means copying from others. Doesn't that conflict, okay, with this with this surge of idea that you want to be yourself? Yeah. So in this class, okay, it's actually designed in a way that you'll be under less pressure in terms of earning the basic grades to pass. Okay, because the hope is that I'm promoting learning, not promoting earning grades with all kinds of means. Some of the means can be quite evil. And so it's then the opposite of what an educator should be doing. All right? So just be yourself. It's okay to be less, but it's actually not that okay. Okay, people don't like others who lie. Okay, so liars, pants on fire. All right? So it will be very embarrassing when the lies are disclosed, and you don't want that. And by the way, Hanjun was asking how you enter the Google Meet room. Yeah, thank you, August. I wish that I can hire you as another TA for the class. Okay, so it's on Discord, Hanjun, and you can enter Google Meet there. All right, however, during the lectures, I actually disable the audio there. But in case you want to ask questions right after the lectures, feel free to stay on as well. Okay, but usually we don't do very close interaction on Google Meet during the lectures. That's so that I can control the lecture time a little bit better. All right, great. Last is, hey, how do I compose all these components, all these categories of grades and turn that into a semester grade? Semester grade. So we are assuming that a sum of 60 being the passing score for the semester. Okay, but in the end, you'll be assigned a letter grade. Okay, and this letter grade is derived from doing this. Okay, so for each of the categories, you will receive a numerical grade, and we'll sum them up, and you guys will all be ranked by the sum. And some of you will be assigned to the A plus or A minus or B plus class. And the cutoff points may vary from semester to semester. Okay, but the goal is such that the concentration, okay, will be at about A minus and B plus. That's between 3.3 to 3.7. So average is going to be about 3.5. All right, so that is the idea of getting the semester grade in the end. So 60 is the minimum for the undergrad students to pass. For the grad student, it will be 70, which is B minus. Okay, so that's something that you want to be careful about in case you are a grad student. Last is just the textbook, class material. The textbook is called Computer Networking, a Top-Down Approach, the 7th edition. Now, if you have the 8th edition, that's even better. But the 7th edition will be sufficient because the differences are not that many. For programming assignments, the Golang socket programming, I would advise using this book, which is online and completely open. Additionally, we have the lecture slides as PDF and available from the course page. Lecture videos on Pollys channel, YouTube channel, and everything else underscored. And all these, we have links available from the course page. And that takes us to quiz 2. All right. So let me change to the whiteboard here so that I can scribble. All right. So for team 2, you'll be answering the quiz as a team. Okay. That means you want to form a team. Minimum is 3 students, minimum 1 student, maximum 3 students. And one of you represent the whole team and type up the solution for quiz 2. And this is what a quiz 2 is asking. Can you write poly emails or messages in Chinese? Yes or no? What exact day is exam number 2? So what is the class schedule? Okay, what day is exam 2? And how much penalty if you submit PA1 at this day and this time? Okay, I think there's a brief presentation about the penalty you might receive submitting these homework late. Okay. And that penalty policy applies to both the PAs and the quizzes. Can you type up questions in Chinese in the live YouTube chat? Yes or no, or both? Okay, so this is actually related to the videos we play, the all English policy. Okay, I said that we are almost 100% English. Okay. Now, one of you represent the whole team, post a reply on quiz to pick on the score. Where is that? That's here. Okay, the W1 quiz 2 channel, and you see the quiz pick here. Hey, I saw someone started typing already. Yeah, oh, nice. Wow, okay, really fast. But you know what? I'm not quite yet done with the description. So what you want to do for quiz 2, and only for quiz 2 is this, because this is a quiz we also collect which team and which of the students belong to which team. Okay, so we'll assign team numbers, and we need to know which of you belong to which team. So make sure you type the name and student ID of all the team members. Okay, and following that, your answers to Q1, Q2, Q3, and Q4. All right, thank you for your patience hearing me out. Now we can go to the scored. Channel W1, quiz 2. Yeah, wow, cool. And by the way, guys, you guys have 3 minutes. Gather your teammates, discuss, and conclude by the 2nd minute. And so you have 1 minute to post your solution on the channel. And I think some of you will run into trouble like, hey, how do you type multiple lines, okay, within one post? That can be done by doing this. If you want to change to another line but not yet submitting the post, hit the shift button and then enter. That should allow you to change the line without submitting the post. So it's shift plus enter to change line. All right, good. Now let's start counting time. Again, to add to the suspense, 3 minutes. All right. Hey, let's check out okay the solutions from you guys. So August Young is a team of three: Ryan and Yuji. Oh wow. Okay, so the last name is long. Komatsuzaki. I hope that I pronounce it right. Komatsuzaki. Uh, all right, so hey, answer for question one, no, of course, because you do have time to think through the English and write it down, right? And the day for exam two, April 30. It is in the week of April 30, all right. Okay. But if I may, go to the course page. You know what? This is a perfect opportunity for Polly to clarify. So, and hey, August, this is not an issue at all because from the video you see that it's from April 30. You are not wrong entirely, right? So from the course page, if you click into the schedule link, you will see also, yeah, for each individual PI, the exact due date and time. Same for the exam, okay? There's gonna be class on March, 26th for exam 1, and the exam is going to be on March 27th. For the second exam, yeah, it's going to be on May 1st because we'll still have an hour of lecture on April 30. All right, so no worries, just correct, okay, in case you get it wrong. So same for Lucas, okay, and this is very precise. Yeah, so when it's live and you're short of words but you really wanted to interact, it's okay to fall back to Chinese in case you couldn't find the term in English. All right, so Lucas, you're almost correct. Same for Vincent and Zewei. And I see that many of you are posting the solutions for one student, and you know what? One student, a team is okay. And later on, when the students are more sure whether they are in the class, then you can try to reassemble and reform for teams. Okay. And I understand sometimes it might be easier. It's easier to expect what you need to do as a one-person team. Okay. Hey, Polly has to admit, Polly is also a loner. Okay, prefers to be a loner. Doesn't mean that I don't like to have friends, but it's more that when it comes to responsibilities, it's very hard to find the right people to share to share for the responsibilities for. Awesome. Is forming with Jia Xuan, a group with Jia Xuan and Ali. All right. 99% of time, no. There you go. Thank you, thank you. Eslim is very attentive, very good. And get to the detail. I like that a lot. Cassandra, glad that you found the scoreboard and glad that you found team members. Yeah, okay, so for Q1, Q3, and Q4, all good. Yeah, the exam day for the second one is May 1st. Guys, try to edit your post, okay? Noah, wait a minute. I thought you were already in another group. Okay, so Noah and Cassandra, you guys. Oh, wait. Oh, okay, so Cassandra, you want to clarify with Noah and Ming Hong who belong to the group. So, guys, the three of you, could you decide to remove one of the oh, there you go. Thank you. And all right. Boyun, you have very good team members, I guess, or hey, you do it yourself. Great solution. Love that. Okay. Well, that's a way of creativity. Okay, drawing a smile on my face. And Yulin here, you know what? Boyun is the first one to get the May 1st right. Yulin too, and Yulin also is in a 3-person group, and Boyun is in a 2-person group. Very good. Zhu Xun also get it right. Nice. All right, so we clarify exam 2 is May 1st. Okay, so the class is 99% in English. Yeah, only when you are really short of words, feel free to type up Chinese. And of course, I see your name, the university record name in Chinese as well. Great. So typically, we'll go through some of these solutions, and we might not have enough time to go through all the solutions. Okay, but it's important that I do this so that you guys can observe each other. Okay, how the other classmates make mistakes, you do as well, and so it's normal. It's okay. But what's important is that you correct. Okay, and whether it's a mistake, sometimes it's questionable because certain details are missing, right? Exam 2 is on the week of April 30th, but exactly, right? We have 2 days of lectures in the week. All right, so that was quiz 2. Now, back to the lecture. And it's time to start the second set of topics, right? And before we start, maybe I should check out the questions on the chat, right? Can we edit messages into... Yes. Of course, Zhixiang, you can edit the messages on the score quizzes. Only in one special quiz, I would ask you to not edit. Okay, but other quizzes, definitely feel free to edit. Minghong, sorry for the duplicate message. No problem. Okay, I think you didn't put an emoji to our answer. Yeah, you know what, Aslam, not yet. And I did not put the emoji on the answers from the rest of the groups we have there. But you know what? Okay. And I'm going to put this one there. Yeah. Aslam, you are very scholarly. Go to the details and very attentive. Good for you. All right. Now we are back to the lectures. And this is the second set of topic. As I mentioned at the very beginning, this is a very high-level overview of the internet. So Polly attempts to teach what the internet is in like 5 minutes. So the first video is to give you the basic components that compose the physical infrastructure of the internet. Now, what is the internet? So this picture that I'm showing is a very coarse-grained view of the internet, where you can kind of see that this part being the ISPs, okay, internet service provider. All there are in these ISPs are just these cylinders with the cross, okay, indicating that this is an exchange. So ISPs, the machines in there are mainly there to do data exchange. And then you guys are here, most of you guys are here. In NTU is an institutional network where you might be accessing the internet through wireless AP, so this is Wi-Fi. Some of you might be sitting in the dorm and having wired connection, having a PC accessing through wired connection. And some of you might be sitting at home, then your laptop connecting to Wi-Fi AP, and then connect to your ISP, and then to the rest of the internet. Now, some of you might be sitting in a cafe. That would be nice, I know. And then you guys are probably accessing the internet through your 4G network and watching the video on the laptop. That is a mobile network there you are accessing, or you can just call it wireless network if you want. Okay, so this is just saying that there are a number of different ways, a number of different kinds of access to the core of the internet. Now, in a little bit more detail and give you the full nuts and bolts view, so meaning the components. So first of all, you see the entities we're using as users are all these, okay, computing devices, PC, server, wireless laptop, smartphones. Okay, and these things are called hosts, or more professionally, end systems. Okay, we don't just call them systems because there's one common feature among these spatial hosts. They are all kind of sitting at the very end of this huge internet. Okay, end systems, very edge of the internet. And then, as I mentioned, right? So whatever machine you're using, whatever end systems you're using, you're connected somehow, right? To a cellular tower, right? To a Wi-Fi AP, to a institutional switch. Okay, so inside NTU, there are also a number of these routers exchanging data because we do have several departments, right? So you see typically institutional networks, there are a few more level of hierarchy than the home network, than the mobile network. But some of you could be accessing the NTUP, a wireless network to the internet, all right? So these access networks, what I meant by access network there are not really there's a network, okay? Really, they are communication links, right? So if it's wireless, then we are using a radio link. If it's wireless and through a satellite modem, it's a satellite link. Now, if you're connected from home, chances high that it's a fiber link. Now, if you are connected through Ethernet I know for sure is copper link. All right, so these are different communication links we might use to access the internet. They can be wireless and wired. Now, these different access link or communication link technologies are all slightly different in terms of this, the transmission rate, the number of bits they can transmit per second, BPS. Now, in this course, computer networks, we also call this transmission rate the bandwidth. It actually meant more the width of the communication band, okay, of the network band. Now, this is somewhat different from if you take electromagnetic wave courses when we're talking about, oh, there's certain frequency band in the EM waves that we're using to transmit modulate bits. Okay, so bandwidth there is also referring to the frequency band. But here, the bandwidth, we actually refer to the network channel band. All right. At the abstract level, it's also a band, but we actually meant the band of slightly different things. And last, yeah, very important entity. Most of us don't see a router in our everyday life. If you want to see one, I don't know, check out these videos released by Google and showing their data center. All these, slim boxes there is a router, okay? And they are running all the time, passing data, forwarding data in really high speed, okay? And by the way, I'm actually saying the routers forward packets because on the internet, the data are usually divided into chunks, okay? And these chunks are referred to as packets. So later on, you'll see me saying data packets or data messages. Okay, I actually meant things that are similar, right? So routers, well, there's just one thing, routers. Of course, these routers are manufactured by a different company, so therefore there are different brand names like Cisco, like D-Link, yeah, lots of them. Juniper, there's another one, a major one in the States. All right, so you see, the basic components are what? The end systems at the edge, and then there are these routers in the middle, in the center. And then these end systems are connected to the routers, or routers connecting to other routers through the communication links. Okay, so that's the basic internet infrastructure. Now the next video is to introduce the end systems that are a little bit different from what we saw, laptops, PCs. So nowadays we have these things called the Internet of Things, the IoTs. They are also connected to the internet. They are also the end systems. All right, so let me say a little bit more about the end systems with this slide. Laptop, PC, servers, smartphones. These are the things we typically use to connect to the internet. But nowadays, if you go to these electronic shops, if you go do a little bit shopping on the Amazon or PC Home, you see there are these generation of new things coming along, and they can all be connected to the internet. They're called these IoT, the Internet of Things. Yeah, things is a very general term because these things don't have a specific form. So they could be internet-capable toaster, internet-capable power meter, internet-capable mattress, internet-capable fridge. And this is a picture frame. Okay. So for example, Watt. This is a smart meter that connects to the internet. And this meter can actually, take the reading and go on Twitter and tweet the reading itself. You can imagine that the power company, power suppliers, energy suppliers can just, take the readings from Twitter without, taking a trip, okay, to your home. a smart mattress, right? So this mattress can sense how you sleep overnight and provide some feedback to you. This can further be made into something that's a little bit robotic, not just being capable of sensing, and so try to adjust the firmness of the mattress so that to ensure you have a good sleep. Smart fridge, I always like to have one of these. So it actually takes, there are cameras inside, so they take actually photos of the milk. So sometimes when I was, in the grocery shop, I would really like to know whether I should be buying milk today. So this smart fridge will be able to remind us, okay, when we're in the grocery shop, whether it's time, okay, to buy milk. Picture frame. I think this is one of the very, very old IoT device. It's connected to the internet, and it was using a way that, hey, so you guys can send recent pictures through these IP frames to your grandpa. So you give these IP frames as a gift to your grandma, and so that every day they kind of see different pictures from you. Now this one is Polly's favorite. It's a smart toaster. So what it does is that it will go on the web and retrieve the weather, okay? And so when you're making the toast, you kind of burn the mark corresponding to the weather today. So as you're eating it, you know the weather seamlessly, okay, without needing to check on the web. Nice, isn't it? Yeah, I wish I could purchase one of those toasters. All right, so yeah, more of these end systems, and it can be very diverse these days. Next video is just to say that provided now the infrastructure, there's edge with end systems and core routers and then communication links connecting all these machines. There needs to run a software on top of it. And the software is huge and is composed by these protocols. Okay? And what they meant is that there's a mechanism controlling how data are transferred. And that internet have a certain structure. You see that it's actually at the high level in the core, it's a network of smaller networks. And so those covers kind of all the components that's composing this very coarse-grained internet. But on top of the physical structure, there are also these rules, okay, that's controlling sending, receiving of the data, right? Such as, this is probably the third time that I talked about this term, TCP. HTTP is the protocol, the set of rules, okay, overwatching how you send data over the web. Yeah, so pretty much for each of the service, there is a specific protocol. For each type of service, for data transferring, there is a specific protocol. And so you see in general, the internet is a network of networks. So this is what? A network of a subnetwork, right? So institution network is a network. Home network is a network. Global ISP forms a network. Regional ISP forms a network. And the internet is actually the bigger network of all these smaller networks interconnected each other. And it's loosely hierarchical. Why? If you look a little bit closer, yeah, this mobile network is connected to actually a higher tier ISP, while this home network and institution network is actually connected to a lower tier, a regional ISP. Okay, so it's not necessary that mobile network is level 2 or level 3. Okay, in this case, it's actually level 2 at the similar level as the regional ISP if they share the global ISP. All right, so this is what I meant here. It's loosely hierarchical. And there are parts of the internet being public, okay, meaning everyone involved, okay, in the society in that region, okay, they will try to donate and to take part in contributing the expense of running that public part of the internet. But for most part of the internet, it's now private. So for NTU, an institutional network to access the institution's ISP, usually we pay, okay. Similarly, at home, you pay the ISP for access. Similarly here, if you're using 4G, yeah, you pay someone to get access. So these, as long as you're paying, that means you're accessing a private network. Okay, there are occasionally public network, not a whole lot, but usually public network. The reason that we don't pay is because essentially we are contributing part of the work, okay, sharing part of the cost already. Okay, by forming a consortium and paying a specific membership fee. Yeah, so that's the infrastructure. We'll take a break for 10 minutes, and then we'll start from talking about the software side. Okay, we'll talk more about these protocols starting next hour. So now let's take a break. All right. Time to come back to the lectures. All right. Oops. Sorry. There. Finally, the music is gone. All right. So the next topic, the software side of the internet. Okay. So this video talks about the service view, which is what I meant by the software side. Now the service view. Okay. To explain, we've learned, right, the nuts and bolts that's composing the physical internet. That is the communication infrastructure to allow us to actually have these applications sitting at the very top at the first place. But the communication infrastructure on its own will not be allow us to send data really that freely. So we could do surfing, we could send emails to each other. Between the apps and the infrastructure, we still have a number of these communication services defined by these protocols. Okay, that's running on each of the devices, running in these routers. Okay, so there's a software component, a service component there as well. Now, two major classes of services that are provided by the internet are these: reliable data delivery versus the unreliable data delivery. Okay, so internet, essentially, it's not just a physical infrastructure, but also an infrastructure with software support so that we could run all sorts of distributed apps on top of the whole thing. There's just one thing I want to clarify. For unreliable data delivery service provided by the internet, a lot of times we just call them the best effort service. Yeah, I know it's a little bit counterintuitive because reliable data delivery is obviously better than the unreliable data delivery. Okay, so why calling the unreliable service the best effort service? Yeah, take note here. We're saying this is best effort service. We're not calling it the best service. Yeah, this is a kind of a polite way of saying that, hey, there's no guarantee. If you recall cases where your friend's asking you for favors, but you know, are not, you know that you don't have time for it already. So a lot of times what you say to your friends, right, politely, is, I'll try my best. Okay, so that's what we meant here, calling these unreliable data delivery services the best effort services. All right, so essentially, reliable service, unreliable services, sometimes they are also called reliable protocols or unreliable protocols. Okay, so service view, the software view, the protocol view. Okay. Now, next is to formally talk about this term protocol. This is so that I can impress you more about this term protocol. It is a slightly more formal way of calling a set of rules, okay? Calling a standard way of parties communicating with each other, all right? So two very simple examples I'm giving, and you know, as analogy to another. One on the left is a human protocol, okay? One asking for another person for information. The other is an internet protocol. One end system asking another end system for information. So you see here, very often when Alice wants to find out what is the time, she says hi, right? And then maybe a friend here catching, you know, Alice needs a bit help. Bob says hi back, okay? Showing that, okay, what do you want to know? Alice says, have you got time? And Bob provided the information that Alice is looking for. Similarly, we as users might be sitting in front of a desktop using a web browser trying to get the content from this URL. So yeah, that browser sends a message to the web server that holds the content. And that server will say, sure, you got my attention. What are you looking for? Client sends, I'm looking for this page. And server sends back the content, okay, of that URL is indicating to. So that is a simple protocol in human world and in the computer world. To sum it up, a protocol, it can be a human protocol or a computer protocol. Okay, so that example you just saw is for Alice to ask Bob for a time, a client asking for a server for certain information, or for you to ask a question. For example, if you raise your hand, right, that's like you saying hi. And if Polly noticed that, Polly says, okay, good, what is the question? Then you start by asking the question. Polly answering the question. So that is the protocol to get a question answered. Okay, so for people first meeting each other, how do you introduce each self to each other? Yeah, so there are specific protocols that allowing human to communicate with each other. Okay, so they are usually involving specific messages and specific actions taken after the messages are received, right? And then so on and so forth, right? You know what? That's very similar in the computer network, okay? And the parties involved are just simply replacing humans with machines, okay? And so all these communications happening in the computer network, okay, are governed by these protocols, where we define messages being exchanged and the orders of them being exchanged, and the actions each of these computers, each of these entities, okay, need to take after receiving certain messages. All right, so protocol defines the messages you exchange across multiple parties, the format of the message, the order of sending the messages, and the actions triggered by sending or receiving these messages. Okay, so that is a protocol. Now, quiz 3. So this is an example of one of those open-ended quizzes that Polly mentioned earlier. So let's give it a try. So let's go to the whiteboard so Polly can scribble. So you know what Polly reads. Okay, I'm a bookworm. So this is from a Wall Street Journal back in 2013. So there's an article, it's interesting, that draws Polly's attention. It says, the delicate protocol of hugging. Yeah. You see that it's actually complicated to greet each other. So human relationships can be really complicated. You don't want to overdo it or underdo it. Now, to greet each other, Americans, depending on the regions the people are from, they do different gestures. For example, Americans hug. Latinos and Europeans do this kisses on the side, kisses on the cheeks. Okay, and Japanese bows seriously. And many of us just shake hands, I have to say. Okay. But the goal of greeting is to try to be polite, right? What else? So in order to be polite, you want to do it in a way that the other side you're greeting with will feel comfortable. Okay, so usually the best principle is to do exactly what the counter side is expecting. Now, yeah, assume that you are in a international student orientation. Okay, and you run into someone who you don't know exactly where they are from. Okay, so what should you do then, greeting another student in such a occasion? Should you bow, shake hands, hugs, or do the kisses on the cheeks? How do you find out? How do you do it such that you ensure that it will be polite and not offensive? Okay, so you see here from the picture, obviously the girl here is feeling a little bit of tension here. Okay, being hugged by a guy. All right, so you know what? Let's go to the score. Channel W1 quiz 3. For this quiz, hey, it's open-ended. So, August, you're really fast. But guys, you're given 8 minutes time. So gather your teammates, discuss. Try to converge at the minute 7, and so that you can type up your solution by the 8th. So no worries, you're given time. And let's start counting time. 8 minutes. Yeah, time's up. Yeah, it's okay. I think some of you might need a little bit more time because sometimes the teammates just have so many ideas. It's okay. This is the open-ended problem. What usually I'm looking for is whether you have some interesting ideas. Okay, so maybe you can walk through a few. So I think a few of you take this a progressive approach. And you try one way of greeting first and see if you can increase the intimacy of the greetings. Okay, so I think this first team, Ryan, Yuji, and August, was going this way. Okay, initially shake hands, which is neutral, and then explore the possibilities, okay, of ways to greet. And so in the subsequent encounter, then you upgrade to another way of greeting. Okay. And another team here from this is Lucas. It's very detailed. Okay. And there's a special design here that is a little subtle, and it might not be easy to do. Right? Lucas was saying that, well, you start the gesture, and then you observe the counterpart's gesture, and then dynamically adjust what to do. Okay, yeah, you know what? Sometimes I do that. I would actually reach out, try to hug, and see if the other is feel that we're close enough to do this. Okay. I know, I understand. In human relationship, right? Sometimes. How close you perceive you and your friend is not entirely bidirectional. So what I meant by that is that you feel that you're close to your friend, but your friend might not feel that close to you. You see, sometimes when you are dating, right, it's a little bit hard to tell, right, if the other side is feeling intimidated enough, okay, to go on. So yeah, human relationship can be a little bit complicated, and you see that in greeting a stranger as well. Okay, so there's an interesting post, okay, from Ke Tasha. Okay, so Tasha, I'm not quite sure whether this should be American pronunciation or the Latin pronunciation. Okay, bear with me, Tasha. Yeah, her answer is just stand and smile. And many of you say that just wave and say hi. So shake hands, we thought neutral, but hey, there are other neutral way of greeting each other. Okay, saying hi or just stand and smile. Yeah, smile is an international gesture. Yeah, so and hey, Polly loves a nice and easy solution as well. Okay, and I think one of the teams said this. It kind of tells the principle. Okay, wait for 1 or 2 seconds for the other to act first, right? And then imitate or mimic what the others is doing. Okay. Now, in case you know each other, then you know what to do. In case the other part just do nothing, try to say something that's neutral or act something that's neutral. Okay, so this is a very complete algorithm, I would say. Okay, this is team. I'm not quite sure which one yet. So by the way, I'll go back to quiz 2. On top of the emoji, I will also let you guys know what the team number is. Okay, and so later on in the future quizzes, when you post the solution, all you need to do is just, this is team number, and then the solution. And it's not necessary to type all the members' names and IDs up. All right, good. So you get the idea of the open-ended quizzes, and you see interesting solutions coming from different students. And I think this group is also interesting. Okay. Saying just hi is a little bit reluctant, right? If you introduce yourself, it means you're also more open. So it's neutral open. So I guess you can have different degrees of being neutral. All right, so great job, guys. And you see that the team exchange sometimes give you a lot of ideas as well. So definitely explore your teammates. It's a good thing, okay, having diverse opinions. And you know what? We should move on, okay? This is the next video is actually to summarize this very high level overview of the internet and to take us to the next set of topics. Now to wrap up. What have we seen so far? Yeah, we do have these hosts or end systems where we run applications. They are sitting at the very end, very edge of the network. And these end systems connects to the internet through the access networks or communication links. They can be wired or wireless, okay, and through different kind of physical technology, physical media technology. And then finally, reaching the core of the internet, okay, which are essentially interconnected routers. Okay, and with all these together, we see the internet is a loosely hierarchical network of networks. All right, so this is the internet. And the next topic is then to dig into each of these components, the edge and the core. All right, so let's start introducing the edge. Now let's take a closer look into each of the components. And starting from the edge. So essentially we have lots of these end systems running applications at the edge. Two very dominant examples, web and email. So for example, this guy here, a laptop. This guy here, a server. Okay, usually server are higher end machines having more computation power or higher amount of storage. So web browser will be talking to a web server requesting for a web page. Okay, so that is called client-server model application, where the client requests for services and receive services from the server. And you see that the expectation of these servers are that they run all the time, 24/7. And that's why these servers need to be higher-end machines, having more computation power, having higher amount of storage, and have more reliable internet connection. Okay, so as we mentioned, web browser here, web server here. Now, some of the pairs could be running email. Then you have email client, which is typically the email reader, and then there'll be email server. So these email servers usually you don't get your hands on. Okay, you don't see them. Just like the web server, you don't typically see a machine. Okay, physically that is a web server. There's another way of communicating the end systems, the applications running on the end system, that is called the peer-to-peer model. Okay. The idea there is to get away without this, always on server. Now, imagine, right? Setting up a web server yourself and allowing thousands and maybe millions of clients in the world to access your web server. You do need a lot of money, right, to maintain it. But some applications might be more grassroots effort where you don't want to be able to afford servers and yet you still want to be able to exchange data. Yeah, that is what the designers of these peer-to-peer applications are thinking. Let's minimize the use of high-end dedicated servers. And instead, why don't we, right, smartphone, laptops, desktops, laptops, just, connect directly as peers, one to another. So there do exist several of these peer-to-peer applications. Skype is one example. BitTorrent, I'm sure that some of you have used it before, is a very dominant example. It's still very popular now. And besides these two, there's one example that you might go, oh yeah, that's right. It's called the Bitcoin or cybercurrency. So that blockchain allowing the cybercurrencies to track itself is a peer-to-peer network. So there's no particular server. That is the whole idea of having these virtual currencies. Okay, instead of having a central bank to overlook everything, to track, record everything, to monitor any of the currency exchange, virtual currency, Bitcoins, it's completely distributed. It's peer-to-peer. Yeah, so the edge of the internet, you have end systems. And these end systems will exchange messages but they can be in two different ways, right? Client-server way or peer-peer way. So the differences between these two models is just that in the client-server way, one end the job is heavier. Okay, so server particularly needs to be on all the time, waiting for clients to access. But peer-peer is more equal parts to each other. All right. Now we move on to the next part that is also in the internet edge, but called the access network. That is allowing the end systems to access the core of the internet. Okay, so now let's move a little bit inward and talk about the next component, access networks. We know by now access nets are there to connect the end systems to the edge routers. What we haven't talked about are that there are several of these access net technologies. In fact, in the next few slides, Polly is going to talk about 5 of these. And depending on where they are used more often, they are classified into these 3 categories: residential, institutional, and mobile. Residential meant home access. So some of these access net technologies are used more at home, deploy more for home environment. Some of these are used more for institutions such as NTU. And some are wireless, okay, so people can still access the internet as they're on the run. For example, 4G is a mobile access network. Now, as Polly gets into the details and talk about each of these access net technology, try to pay attention to the bandwidth each of these technologies promises. Some of them offer higher amount of bandwidth, some lower amount, and some offers symmetric amount of bandwidth between downlink and uplink, but some offers more downlink and less uplink. Pay attention also to how the access net is being used among the users. Some access nets give you this amount of bandwidth, but all the users accessing the network will share the bandwidth. So if there are more users, each one gets a smaller cut. But some technologies actually offer big bandwidth, and that access net will actually allocate a specific amount to each of the users. So each of the users will be guaranteed a specific amount, which is dedicated. Okay, and if there are more users, none of the existing users will suffer. Yeah, so that's access net. So next, Polly is going to introduce 5 of these access net technologies. Okay, some of them for residential access more, some of them for wireless access more. Okay, and for each kind, pay attention and see if you can tell the bandwidth, which means how fast you can send the data over such an access net per unit time, and whether the bandwidth is shared by many of the users downstream or dedicated to you. Okay, usually we like that the bandwidth is dedicated to us. Okay, so now first stop is called the DSL. The first technology is called the DSL, digital subscriber line. This is pretty much a legacy technology, which is building on top of yet another almost legacy technology called the telephone network. So let me draw your attention to the example at the top. Where the telephone network is, starting from here, the phone set, okay, where you make a phone call. So the signal is going to travel through the phone wire to the hub on the wall. There are lots of also wires behind the wall, connect you through the central hub in the building and then out on the streets. And there are quite a few cables buried underground, especially for Taipei City, and those cables take the phone calls to the central office. And inside the telephone company, there are these switches. They're switching the phone calls, and eventually the phone call reaches a friend that you're calling to. So this is the telephone infrastructure, and it has been there since, I think, late 19th century. But starting, I think, late 20th centuries, we want to do this. Okay, generating emails from our home PC and send that to a friend somewhere else, okay, connected also to the internet. Now, to allow this home PC to connect to the internet, we borrow the telephone infrastructure, particularly the cables and the wires we have in the buildings under the street, so that we could send the data somehow to the central office of the data network providers here. And the way it works is this. Let's assume we're sending an email to a friend. So that email is going to go and reach the DSL modem first. So DSL is the name of the technology. Modem here is actually modulator and demodulator. Okay, the first few letters combined. So what it does is, hey, email coming from your PC is in digital form. It's going to be converted to the analog form, so it can go on this cable here and multiplex potentially with analog phone calls coming from the phone set. So these together can travel the cables and reach the central office of the service provider. And by the way, very oftentimes the telephone service provider is also an internet service provider. Now, once they reach the central office, this big box, DSLAM, it's DSL, I think access multiplexer, okay, whatever it's called. What the functionality of this yellow box is simply, first, split the analog signals. Some of those could be analog voice for the telephone network. It will go on this way. Some of those are for the internet. It will go on the other way. And before this analog signal can go out to the edge server, DSLAM also demodulate the signal from analog back to digital so that it can travel the digital data network. You can imagine vice versa. Your friends send an email back through the edge router and reach the big yellow box, and that email gets converted to the analog form and multiplex with the phone calls together, traveling the cable, and finally reaching the household. First, go through the splitter. If it's phone call, go this way. If it's internet data, go this way. Now, at this point, the internet data is still in analog form, so modem here demodulate from analog signal to digital, and therefore you get to read your friend's response. Now, if you think a little bit more about the yellow box, what it does is essentially what the blue and the green box are doing combined. Modulating and demodulating, multiplexing and demultiplexing. What is a little bit tricky there is so that how do we do the modulation right, and how do we do the multiplexing so that the voice and the digital data will not interfere with each other. And that is done and achieved by, by splitting the frequencies of the EM carriers. So what how we are sending data or in analog or digital form is that we are modulating these signals onto the EM wave carriers. So we modulate the analog voice to this frequency band of the carriers, and upstream data to this frequency band, downstream data to this frequency band. And they are mutually exclusive, therefore they won't be interfering with each other. Okay. So phone is going through the 0 to 4K hertz frequency band, and upstream data 4K to 50K hertz, downstream data 50K hertz to 1 megahertz. So you see that the downstream data is using a wider frequency band, and so not surprising, upstream bandwidth only 1 megabits per second, and downstream we get 80 megabits per second. The last about DSL is this link here. Yeah, this is one link per household. This is very dedicated, okay, between the central office to the user. Yeah, so DSL, it's an outdated technology, but it was really popular. Okay, some 1 decade ago, maybe. Next one is called the cable modem. The way it works is somewhat similar to DSL. Okay, again, pay attention to what the bandwidth it offers and whether the users are sharing the bandwidth or the bandwidth is dedicated. So, cable modem. And the second access net is cable modem. A little bit similar to DSL, it's also for residential access. And unlike DSL, which is exploiting the telephone infrastructure, cable modem there uses the cable TV infrastructure. Yeah, you see, we also have lots of wires behind the walls leading to a central office, leading to the cable company. That's how we receive the TV programs. So, cable modem here, exploit that existing infrastructure. What's nice about the cable modem is this. The bandwidth available, it's also asymmetric, where you see the downstream bandwidth and the uplink bandwidth different. In cable modem, wow, lots of downstream bandwidth, 30 megabits per second, but very limited upstream bandwidth, only 2 megabits per second. If you judge based on only the amount of downlink and uplink bandwidth from cable modem and compare it to DSL, you'll see, whoa, cable modem wins, obviously. Yeah, for DSL, this is only 8, and this is only 1. But you want to be careful, though. These cable fibers attaching household to the cable company, they are shared access links. Unlike DSL, these telephone wires are dedicated access. That is saying, oftentimes a cable company will set big cables, center cables from the center office to a neighborhood. And there's going to be a splitter that splits TV programs and across hundreds and maybe thousands of households. Yeah, if you use cable modem, sending data, your data and all your neighbors' data will be multiplexed on that cable and to the central office. That cable there is not dedicated, it's shared. So even though the bandwidth is higher, but you can, be competing potentially with all your neighbors. And it really depends on how many people are subscribing to the cable modem service in your neighborhood. That determines really the quality of your internet access. To illustrate, let me show you this example where we're connecting hundreds and thousands of households together through one major pipe to the cable company. And inside the cable company, you see often lots of these video servers, and stored on these video servers are the TV programs. So the cable head will stream these videos down this way. Gets split here, 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 here. Okay, depending on what each of the household is requesting. Okay. Occasionally also, from the household, there could be some control messages being sent, for example, to switch channels, okay? For example, to turn the TV program off. Now, if you have the cable modem installed at home, the infrastructure is going to look a little bit more extended, but most of the extensions are inside the household, as well as in the central office of the cable company. Yeah, I know. If you look at this picture here, you see, very familiar, right? Just like DSL. If there is signal coming in, the splitter here will check. If it's TV program, it will go on this way. If it's data, internet data, it will go on this way. And the cable modem will convert it to the format that's readable from our PC, and therefore you read the message from your friend. And similarly going out the other way, right? So your message will go out from the household and through the shared pipeline to the cable company. And inside the cable company, there is this big multiplexer and modulator that's doing the right thing so that your internet data goes on to the rest of the internet. Okay. And your friend sees your message. Now, be careful here. There's only one cable here. If there are messages coming from this other household or this other household, they will all get merged onto this cable. Now, these messages coming from the household, they will share the same channel and compete for the bandwidth there, unfortunately. Another thing that you might find surprisingly similar between cable and DSL is this: how we are multiplexing the original infrastructure networks data as well as internet data. And this is how cable modem is doing it. These first few channels are video, data, and last one, control. The channel towards the left, lower frequency. The channel towards right, higher frequency. So essentially what you're seeing is that the entire frequency band allowed on a cable network are divided into some subbands. Okay, so 1 to 6 are for videos, which are the TV programs. 7A, in this example, are for the internet data. And then these control messages, such as switching to a different channel to a different TV program, is only just one subband, right? And so they kind of run on frequency subbands that are not overlapping, completely separated, so that they would not be interfering with each other. Okay? So that technique is formally called frequency division multiplexing. Okay? So we kind of cut the entire frequency band into non-overlapping subbands, division over frequency. hence the name. All right, so that's cable modem. Now we can actually compare the two access NAC technology, DSL, cable modem. If you recall, DSL, the bandwidth is lower, right? 1 megabits per second uplink, 8 megabits downlink. Cable modem, bandwidth is bigger, 2 megabits uplink and up to 30 megabits downlink. But you see also that, hey, DSL is dedicated, so you have the entire 1 8 megabits bandwidth uplink downlink. But cable modem is shared. So this 2 and 30 megabits per second uplink downlink you will need to share with your neighbors. Okay. Now, so this is the next thing what I want to do is to ask you, okay, based on your intuition, DSL cable modem, one lower bandwidth but dedicated, the other higher bandwidth but shared, which one you prefer? Okay, so can you type it up on the chat? DSL or cable, which one you prefer? Okay, so this is also an opportunity for you to participate. So it's DSL and if I have to for August. So I guess what August meant is that it's a little bit hard to choose. But if I have to choose one, DSL. Hey. Oh, and August added OFC. If OFC is possible. By the way, August, OFC is the third, the FTTH, because OFC in Taiwan is called the fiber to the home. So I guess these technologies coming to different regions in the world are also called slightly differently. Is negligible. So Ryan is saying, okay, yeah. But we do also have some students saying cable, right? I guess these are, Cassandra, Junix, you guys are probably heavy users. For heavy users, yeah, sure, let's share. Evo are internet provided by TV company in Taiwan. Yeah, I think many of the Taiwanese residential access are still cable modem. That is because these cable modem access are very cheap. And the reason that cable modem access is cheap is because the cable TV network is already built in. The deployment cost is already covered. Okay, all the cable company needs to do is just to install these splitters and modulators. Then they can start operating. So cable modem is cheap because the whole infrastructure is in place. For DSL and the fiber to the home, FTTH or OFC, you have to actually bury these cables underground or pull them around over the sky through the poles to get connections. So these are wired links. So physical cables needs to be somehow established. So DSL and the OFCs are also more expensive. Yeah, so if you consider cost, I guess you guys will also change the choice. Yeah, and guys, I think some of you choosing cable are probably because of the cost, because many of the Taiwan students, right, say cable because they are obviously cheaper. Yanjia had a change of mind, DSL, I see. You know what? Hey, this is, what you like. It's a personal choice, okay? As Polly introduces more access NAC technologies, hey, Polly might ask you again whether you prefer DSL or FTTH, whether you prefer cable or FTTH. By the way, Ethernet in its very original form is also shared like cable. All right, but you know what? That's all the time we have today. We have slightly less than 2 minutes, but I want to go back to this. The welcome and rules that we have not yet finished talking about. Okay, so point number 3 is to post question comments in the corresponding channel. Okay, so PA questions go to PA questions channels, and the exam questions go to the exam channels. For a particular quiz, it's okay to stay in the quiz. I see Noah. Yeah, Noah actually liked Tasha's solution, but posted here. But hey, guys, Noah and August, feel free to let Tasha know in the Quiz 3 channel. All right, good. So rule number 3 is make sure that you focus the discussion in the particular channel, because if you ask question there, it provides an opportunity for the rest of the class to interact, right? And allowing others to see how others interact. Okay, and it's completely okay. If it's, truly coming from your mind. Okay, I mean, why do you need to be ashamed of saying what you think? If it's wrong, it's wrong. You say, yeah, so maybe I'm a little bit mistaken. And I see that there are other opinions about the same thing. Okay, and so you take others' opinions into consideration, and maybe you adjust your opinion. Okay, hey, that is called the learning process, in fact. Receiving an answer faster also, right? So if you post the question at the right channel, then not just Polly, but the rest of the class can all contribute and try to answer. Okay. Number 4, feel very free to speak up and share what you have in mind. So I guess there's no shame or no shameful answer here. Usually, if you speak from your mind, you'll be fine because it's true. Right? It's true to you. Now, of course, there'll be things that Polly talk about that's technical, and you might get it wrong. But hey, what's wrong getting things wrong, getting ideas wrong? There's nothing wrong with it. People get, ideas wrong all the time. So you just, get an opportunity to clarify, and then you correct, okay, what you originally thought what DSL is, what cable modem is. And we do not discriminate anyone on any basis here. Know that we do have domestic students and international students. Please do consider our differences. So the value systems in other countries can be very different from the value systems we have here in Taiwan, right? I understand for many domestic students in NTU, because most of the NTU students are selected because of their grades in high school. And therefore you thought that you'll be continue to be selected based on your grades. Well, I hope that stick around. That might stay until the grad school. But after that, no. So you still want to build your strengths to learn new things, okay? And overlook a little bit of what the grades mean, right? So see, if you don't like to be discriminated, you do not discriminate others. And international students, of course, don't discriminate the domestics either, right? We're just different, okay? So I think the solution for that is just be kind, be considerate, okay? That will take you a long way, in fact. As soon as you start working, you'll find that being kind and understanding is the best way to build friendship, to build particularly long-term friendship, to find reliable partner for projects that you need to share responsibility with. All right, good. So that's all for today, and I will see you next Tuesday. And by the way, good news. Next Wednesday is Taiwan's national holiday, so no lectures, particularly to the international students. So I see you Tuesday. Goodbye. Bye.